Welcome to Year 7 Maths videos. As always, I encourage you to skip forward anything you already know or watch on a faster speed if that suits you. Alrighty, welcome to Unit 3 textbook for my first video. And for my first trick, I'm going to tell you how to revise or what we need to revise for this factor. So first one here you can see is 3a, factors and multiples. Now a factor is simply the numbers that times together to equal a bigger number or divide into that number. So for example, if we had, let's start with something easy like 10, the factors of 10, and they often come in pairs, would be 1 and 10, because 1 times 10 is 10. It'd be 2 and 5, because 2 times 5 is 10, and that's all. That's the only factors. There's 4 factors of 10. Now, multiples is like if you said what is a multiple of 10, you would be saying what is the answers to the 10 times table. So you'd be counting up by that number. 10, 20, 30, 40, and that's messy writing, but 50, and so on. They're the multiples of 10. Okay, so the factors are the numbers that times into it, and the multiples of that. And then that leads into this idea of HCF and LCM. That's highest common factor and lowest common multiple. Okay, so if you had two numbers such as, let's say, do something easy again, 2 and 10, and you said what is the highest common factor between 2 and 10? Well, you can list the factors of both things. So factors would be 1 and 2 for that. That's all there is. And for 10, again, I won't write it, but it's that up there. Then you look at both lists and you say, out of the two lists, which is the biggest number that's in both? Well, in this situation, there's only one number in each that is the same. So 2 and 2, that would be the highest common factor because that is the only one that's in both, and it also happens to be the highest. As far as 2 and 10 goes with the lowest common multiple, then you've got to list them out like this, these multiples. So you don't really need to list out the smaller numbers, or the bigger numbers rather. Sometimes you do, but not in this situation. So you list 2, 4, 6, 8, 10, and so on. You could get going, but the lowest common multiple, so that's the lowest number that appears in both lists. Now the first to appear in both lists is 10. Therefore, the lowest common multiple of 2 and 10 is 10, and the highest common factor is the 2. Because that's how good. And one little trick with highest common factor, what you should always try and do is see if you can divide the bigger number by the littler number. If you can do that, then that automatically is your highest common factor, because you can't divide 2 by something higher than 2. Not in this case. You can do it if you want to get a decimal point, but not a whole number. And then in addition to that, if it was like, say, a number by 10, you'd say, okay, can I divide by 10? And the other number by 10? No. Can I divide by 9? No. 8? No. And you just keep going down from the smallest number until you find something that can be divided, or that both numbers can be divided by. So there's that. Now we've got 3D, which is prime and composite. Now that links with these. I didn't factor these announcements in when I made this video, but I'm not redoing it now. So 3D, prime and composite. So prime numbers are any number that doesn't have any more factors than 1 in itself. So prime numbers are numbers that only have two things that can be divided by, 1 in itself. So 7 can only be divided by 7 or by 1. So the only factors of 7 are 1 and 7. They're the only factors. 10, for example, has all those factors up here, but 7 only has 2. So you know that's a prime number. If it was like 20, or rather 19, you can't divide 19 by anything equally. Therefore, the only factors of that are 1 and 19, and therefore that is a prime number. Now, one trick with prime numbers is if it's ever an even number, which means it ends in 0, 2, 4, 6, 8, then it's never a prime number, because it can always also be divided by 2. Now that's not entirely true, because 2 is also a prime number, and 2 can only divide by 1 and 2, so it's a prime number 2. But it's the only one that's even that is a prime number. Composite is basically any number that is not prime. So if it has more than 2 factors, it's a composite number. So move on from there now. So now we're talking about 3e, and we're talking about index form. So we're talking about this 7 times 7 times 7 times 7 times 7 can be simplified to, well, you just write the same number that is there, and then how many there are. So there's 1, 2, 3, 4, 5. So 7 to the power of 5. That's how you simplify it. That's what it is, the index form. Now, on the same token, if they were to say, let's say 6 to the power of 3, and they said write that in expanded form, well then you would just write 6 times 6 times 6, and there are 3 6's there, therefore that's where the 3 comes from. That's how you know. Then how we evaluate that out here, you'll see that's more complex. So you need to follow the BODMAS idea in that. Brackets, this is of, but it's really short for order, which are these indexes. So brackets, indexes, then division, multiplication, so do that, and then the minus. So let's talk about it now. Let me just delete that part there. So what you do is what's in the brackets first. So you'd say, let's say 4 cubed minus 3 times, and then you do what's in the bracket. So 2 with the 4 is 2 times 2 times 2 times 2, which is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it's 16 minus 3 times, and then the 3 squared is 3 times 3, which is 9. So it's 16 minus 9. So this equals. Then you go, and you can do more steps than that if you want. You could have done this one too, but let's say 4 cubed minus 3 times. Actually, you probably should have done that one at the same time. But if you don't want to do more steps, never a problem to do more steps. Then if you want to cut out steps, is maybe sometimes bad. So, all right. So 4 cubed is 64. My bad. The rush of having to do it faster, and the thing really got to me. Anyway, equals 64, 4 cubed, and then minus the 21 from the 3 times 7, and then you work that out, it would be obviously 43, which is C, and that's the answer for that one. 3F, for each number draw a factor tree, then write the number with powers of prime factors. Alright, so here we start. You start with any number, 50, and you got to divide it by 2, find its factors. Now you can do it by a prime number, you don't have to, but at the beginning, but then you should after that if you can. So 5 is a prime number, so we can do that by 5 and 10. So 5 times 10, that equals 50, right? Now, can you divide 5 by anything? No, because it's a prime number, so you've got to do the next stage then. And then 10, what can you divide 10 by? Well, you can divide it by 2 and 5. And so 2 times 5 is 10, and they are actually both prime numbers. So because of that, that's the final answer. So therefore, it says write numbers with powers. So what you have to combine the same numbers. So it's 2, 5, so it would actually work out being 2 times 5 squared. I think they usually like you to put them in ascending order. So the lowest number goes over here, then it goes up from there. If you need to see another one, I'll do a bigger one of that, although this video is getting pretty long already, but 2400 divided by 2 and 1200, and that one's already done. So then you go divide that again, let's say 2 and 600. Do it again. Let's do it by something bigger this time. Oh, let's just keep doing it. 2 and 300. 2. You have to do a step for each level. And 2 and 150. Need to do this out. And you're supposed to put times in all of these spaces. And then you have 2 and 75. And again, you have to follow these all down, which I'm not going to do in the video, and just keep following them down. Then you'd have to do, well, maybe you don't have to do that part. If you know what you're doing, actually, you probably could leave it, but the book sometimes did it. And you've got 5 and 25, then you've got 5 and 5. So now you're left with 5, 5, 5, 2, 2, 2, 2, 2. So that would be 2 with 5, because there's 5 2's, times 5 cubed, because there's 3 5's. Let's say 27, like that. So you can say, well, let's divide it by 3, which equals 9, divided by 3, which equals 3, divided by 3, which equals 1. You can say the prime factors are 3 cubed. Sorry, that was divided by 3. I only had 4 hours sleep last night. 30 divided by 2, and then 3, so actually, sorry, is 2 times 3 times 5. I'm going to have to edit this anyway. Alright. Then 3g, here, you say evaluate this. So it's just 3 squared, which is 9. Then 4 squared, which is obviously 16, which equals 25. But you don't do the, even though it's kind of like dividing, finding the square root, which is the two numbers that times together that equal that number, and you calculators have the question, like the button in it too. Even though it's not in brackets, it seems, at least as far as the textbook's considered, that you don't need to have any brackets around them. You just put it together because they're all under that. If it had been, yeah, I get it. So if you had just had it like that, a short one, then yeah, you do all that first. But because it's over both of them, it counts as that. So then you find the square root of that, which is 25, because 5 times 5 is 25. So that's a squared number. Then this, so that one here, the 10 cubed one, so 10 cubed divided by 3 squared plus 4 squared. So you can just, 10 cubed is 1,000, because 10 times 10 times 10. And then that would be, again, 9 plus 16, which effectively is 1,000 divided by 25 square root of, which is 1,000 divided by 5, which equals 200. That's how you do that one. Alright, these input outputs, alright, in 3J. It says output equals 2 times input plus 7. So here's the input, so 2 times 4 effectively, plus 7. 2 times 4 is 8, plus 7 is 15. So here would be 2 times 2 plus 7, so that's 11. 2 times 9 is 18, plus 7 is 25. 2 times 12 is 24, plus 7 is 31. And 2 times 0 is 0 plus 7 equals 7. So let's see how the input outputs work. And here it says output equals input minus what? So output equals this minus something. So what do you have to minus off 15 to get to 9? 6. What do you have to minus 20 to get to 14? 6. What do you have to minus 28 by to get to 22? 6. So the answer is clearly 6. And it says copy this, 2 times input minus 1. So 2 times 1 minus 1 would be 1. 2 times 2 minus 1 would be 3, because it's 2 times, and 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. You see it's going like that. And we've got to list the coordinates, 1, 1, 2, 3, 3, 5, 4, 7. Now the first number is always on the x-axis. So this point would go 1 up here and 1 there, so it would go in there. Then it says 2 and 3. So here's 2, and we go up to 3, goes there. Then 3 and 5, here's 3, up to 5, and then here's 4, and then up to 7, which would be up here. And you can see the line there, that's how you plot them. And that's Unit 3 in a nutshell. Hopefully that was helpful.